A simple introduction to derivatives. Take the definition of derivative using the limits. Now, to find the first derivatives using the limit definition, we write first of all the rules. F prime x, or the first derivative, is basically limit fx plus h minus f of x divided by h as h goes to 0. Now, we substitute these terms into the function given in the question as you see in front of you. We simplify it and we reach until the last point, which is limit 3 of h divided by h as h goes to 0. And at this point we can eliminate h because it's a common between the numerator and denominator, and the answer will be 3. We start with another example. Find the first derivative using the definition. The definition again, limit f of x plus h minus f of x divided by h as h goes to 0. We substitute those terms into given function. We do the simplifications and we end up having limit 2xh plus h squared minus h divided by h. We notice that h is a common factor at the numerator. We take it out, we delete, and we substitute by h equals 0 at the last stage to find out that the answer is 2x minus 1. Now we will summarize the basic rules of derivatives now in the comment section of this lesson. We will start with the first rule, which is if f of x equal constant or any number, then the first derivative f prime is always equal 0. For an example, if f of x is equal or g of x equal 5, then g prime equal 0 without thinking. Another example is illustrated in front of you. Now, we go now to the second rule. If f of x equal x, which is basically 1x, then f prime is the coefficient of x, which is 1. If f of x equals cx, where c is any number, then f prime is gonna be c. Take the following example. If f of x equal minus 7x, then f prime is the coefficient of x, which is minus 7. If g of x equal 3/4 x, then again g prime is 3/4 or 3/4, which is the coefficient of x. Now we will go to the powers rules. If f of x equal x to the power n, where n is any number indicating the power, then f prime is equal n times x to the power n minus 1. Look at the example. If g of x, I will highlight the greenish one, equal square root of x, it is basically x to the power 0.5. Now to apply the derivative rule, all what you have to say, it is the power 0.5 times x to the power 0.5 minus 1, and then simplify it as you know before. Thus it will be 0.5 times x to the power negative 0.5. If you don't want to see a negative power, you can just drop x with the power below, and it will be 0.5 over x to the power 0.5, which is 0.5 over square root of x. Now, if f of x equals c times x to the power n, where c is a number, all what you have to do, the same power rule, but you will multiply it by by c. For an example, g of x equal 3 times x to the power 7, then g prime equal 3 times 7 times x to the power 7 minus 1, and at the end it will be 21x to the power 6. Again, we will speak about the radicals rule by taking the following example. F of x equal 5 times the third radical rule of x squared. We know that the third radical rule of x squared is basically x to the power 2 over 3. Now we apply the power rule. We say the derivative is the power 2 over 3 times 5, which is number c, times x to the power always minus 1, 2 over 3 minus 1. And then we simplify it as before. It is always acceptable to distribute the derivative over the plus operation and minus operation. As you can see from the example in front of you, if f of x is a polynomial 3x cubed minus 2x squared plus 1 and he's demanding f of prime, then you will take the derivative of each term alone. Thus the derivative of 3x cubed, it is 3 times 3x to the power 2, which is 9x squared, minus the derivative of 2x squared, which is 4x, plus the derivative of 1, which is 0, and so on. It's easy. Take another example. G of x is 10x to the power negative 5 plus 4x cubed minus 2x. Then g prime will take the derivative of the first term, which is minus 5 times 10x to the power minus 5 minus 1 to end up minus 50x to the power negative 6, plus the derivative of 4x cubed, which is 12x squared, minus the derivative of 2x, which is minus 2. Now we will move to the rule of multiplication. Let us start illustrating it. If you have a function f of x with a derivative f of prime and g of x with a derivative g prime, then the derivative of their product is gonna be f prime g plus g prime f. And it's easy to be memorized. Let's start with the following example. He's asking us to find the derivative of their product. First of all, you will have to prepare the stage. If f of x equal 3x, then f prime equal 3. And g of x, 5x squared plus 1, then you will find g prime equal 10x. Now, you will follow the rule. You have to memorize the rule, which is f prime g plus g prime f, and then you start replacing the values according to the rule illustrated. You do the simplification process, you continue simplifying until you receive the last answer. Now we will move to the rule of division or the quotient rules. Again, we assume there is a function f of x with a derivative f prime, g of x with a derivative g prime, and then you've been asked to find the derivative of their division, of their quotient. You have to memorize the rule again. It is f prime g minus g prime f over g squared. Now take the following example. You will find first of all f prime for 5x plus 1, f prime is 5. For g, 3x minus 4, g prime is 3. All what you have to do, you will write the rule and then you will replace the values. You will simplify it until you receive the final answer. Take another example. He's giving you already a fraction and asking you find immediately the derivative. You will assume the numerator to be called f and the denominator to be called g. Now from f equal x cubed plus 2x, f prime is gonna be 3x squared plus 2. The denominator g equal x minus 1, and accordingly g prime is equal 1. And then you have to write the rule f divided by g all prime equal f prime g minus g prime f over g squared, and you replace the values. You do some mathematical operations to simplify the quotient in front of you, and then you get the final answer. Tangent lines and their equations. Whenever he gives you a function, you are advised always to find the first derivative of that function, because this first derivative will represent the slope of the tangent line at that specific point. Take the following example. If y equal x squared, then find the equation of tangent line at x equal 3. Firstly, we take y equal x squared and we find the first derivative y prime, which is 2x, and we use x equal 3 given in the exam, and we replace it there. This 2 times the 3 equals 6, and by the way, this is the slope of the tangent line. Now, we're not done with x equal 3. We go back to x equal 3, which is given in the question, and we substitute it again in the graph given in the question, in the function given in the question, which is y equal x squared. Like this, you have created a point, which is 3, 9, and you have found the slope m equals 6, and then you go back to grade 8 and you apply the equation of the point slope, and you will say, okay, my tangent equation is y minus y1 equal mx minus x1, and you replace the values as you can see in front of you. It's easy. The trick here is always to keep in mind that the slope of the tangent line is basically the first derivative. Okay, take the following example. Now, f of x is equal 1 over x. To find f prime, you have to apply the rule of quotient and then replace it with the value at x equal 2, and voila, you find the slope, which is minus 1 over 4. Again, you're not done by x equal 2. You have to go back and replace it in the function. You have now created a point which is 2.5. You have found the slope, which is m equal negative 1 over 4, and you will use the point slope form of linear equation, which is y minus y1 equal m times x minus x1. You replace the values, and if you wish, you can simplify it further to get the final answer of the equation line, but mathematically this is acceptable answer. Now I'm showing you, if you simplify it, the answer will be negative 1/4 x plus 1, and this is the equation of the tangent line at x equal 2. That was the end of the lesson. Thank you so much for listening.